Hey folks, thank you for stopping by this talk. I am Eli, one of the co-founders of Atomic Jar, and I'm here to talk to you about doing testing, real integration testing with real dependencies without having to worry about containers or anything else. So first I'll talk really briefly about Atomic Jar, the company I'm from. I'm the co-founder of. We're building developer tools. We want to transform how teams build software and make it easier to do so. We are the custodians of the Testcontainers framework, which is used extensively by lots of companies around the world, including Spotify, including Netflix, Uber, and others. All of those have talked publicly about their use of test containers. We're seeing about 6 million downloads of this technology months, and we now support 6 official languages, including Java, JavaScript, Node, .NET, and others. What we've been looking at is how do people do testing, right? So when you start learning any language, you start with, let's do mock development, right? Or mocking dependencies. It's fast, but it's false and it's hard to maintain. You look at staging environments or QA environments, right? Which is great, which is how many people do integration testing today. It's great, it's realistic, but it's fragile and slow. And in reality, staging environments are susceptible to data drifts, environmental issues, and so on and so forth. That's a challenge for them. They do not scale with time. Then people do testing in production. In fact, all of us do testing in production. Some of us just do a little bit of work before we roll it out to production. It's real, it's great, but it's expensive, and it has real impacts on your users. Testcontainers, the framework we're building, solves that. It's fast. You're able to have instant feedback. You're able to get feedback even before you commit your code into Git or anywhere else. It's realistic because you're testing with real dependencies, and it's cost effective because you're able to do it from your local machine. You're able to do it from CI and everywhere else. Testcontainers allows you to define your dependencies as code. It allows you to run a couple of lines of code, and I'll show you in a minute, and define what your what your tests are going to need as dependencies. So you're able to write a unit test and say, hey, before this unit test runs, I want there to be an instance of Redis, or an instance of Kafka, or an instance of MySQL, or any other dependencies. And what Testcontainers will do is before your test case runs, it will spin up those dependencies for you, run the test against those dependencies, and when you're done, blow it all away. It allows you to create self-contained, idempotent, repeatable tests that and maintain all of the lifecycle of your dependencies and do it directly from your code. You're able to do it for your entire stack. Anything that can be run as a container can be tested that way. And it's implemented in at least in 6 languages, and we are building even more implementations of this. I'll do a quick demo, if that's okay with everyone. Let's dive into, there we go, can we see? Or is it too small for folks to see? Let's see if I can. It's been a while since I've done. Is it possible to see what's on the screen, or it's too small for folks? It's a bit small. Okay, let me see if I can zoom in real quickly over here. Can someone help? Control plus, Command plus. Okay. I am gonna continue over here. I hope you'll be able to see. It's I should have prepared for this a little bit earlier. Apologies. All right, so what you're seeing on the screen over here is you're seeing typical test cases. I am testing an endpoint that I'm spinning up. What's interesting about this test case is that this test case inherits from integration test, where I am, there we go, where I'm saying the following. I'm defining a property, which is a property to spin up Postgres. So I'm spinning up real Postgres over here. I'm defining that I'm going to need a new, a Confluent database, so a Kafka. And I am saying that I'm going to need a Redis instance. So in my configuration, I'm defining this. And when I go back into my test over here, I'm able to run this test code over here. And what it will do, as soon as Gradle builds and everything else, it will run this test case in real time. And what you're going to see in this output is what it's doing in the background. It's going to spin up those 3 containers that I just defined, Postgres, Redis, and Kafka. It's, oh, there we go, fun. Real life tests, real life demos, and I have an illegal character somewhere. Oh, because I just typed something into my window. Let's rerun this again and see it working, hopefully. Random typos in my code. So what it will do over here, it will run those dependencies, it will spin them up for me, it will run the test case against this, and when it's done, it will all blow it all away in real time, and it will do it as soon as Gradle is done. It will do it, should be done in less than 30 seconds. Maybe, maybe not. All right. I'll switch back to my talk, and then I'll come back over here. There we go. So what it's doing over there, it's managing the lifecycle of those dependencies. So it is spinning up containers and spinning it back down. I no longer have to worry about the lifecycle of those dependencies. It's integrated into JUnit. It's handling all of the ports, logs, all of the setup, all of the teardown, and all of that. It also supports Docker files if you need to, and all of those things. We also have over 50 things that we've pre-built, over 50 integrations with various databases, and we've built it in such a way that that it's aware of the particular dependency. So it knows for Kafka to look up for Bootstrap servers and so on and so forth. I think it's alerting me over there that the test has run. You're seeing Spring. You're seeing the various containers being pulled, and the test executing successfully in 3 seconds, 51 milliseconds over here after Gradle build has run successfully. Sorry, I'm switching back and forth. I've mentioned about the various integrations. What we've most recently done is we've partnered with a number of vendors from this list, and they're now supporting and maintaining their own integrations with test containers as well. This is something that we've launched about a month ago. What I haven't talked to you about is when I ran this test case behind me, it was open source test containers that was running, but in reality, on my laptop over here, I do not have Docker. So when you run test containers open source, you need local Docker as the execution environment because it spins up containers. What I'm doing over here is I'm running a client-side agent, and that forwards the requests to Docker to public cloud instance that we have. Testcontainers Cloud is what we're using as a backend. It allows me to separate the resources of my local machine and where my dependencies are running. It allows me, for example, over here, I'm running an M1 laptop. It allows me to have the whole breadth of dependencies that I can run on an Intel architecture running over here. It allows me to get multiple resources. It allows me to have exactly the same backend between what I'm doing in CI and what I'm doing on my desktop. Right? And it gives me more reliability in my test suites because I am no longer resource constrained by what my local machine over here can handle independently. In the backend, what's happening when I'm running Testcontainers Cloud is I'm running an agent, either in development or in CI, which goes to our public cloud, provisions resources, and is able to run all of those dependencies. In reality, my code never leaves my machine. It's just the dependencies that are started We're using encrypted tunnels, and we're using VM-based isolations on those machines in the background. And by doing Testcontainers Cloud, we're able to do more things. We're able to, for example, give you visibility into what you're testing with. So you're able to see activity, who on your team is doing testing when, and what are the most active days when your team is doing testing. What you're also able to see is you're able to see what are the dependencies you and your team is testing with. So if you're trying to migrate from Cassandra 3 to Cassandra 4, you actually have visibility into who is doing testing with which dependencies, who will be ready when, for example, a central team decides to stop supporting Cassandra 3, for example. What you're also able to do is you're able to have better visibility into your test runs. So now, because you're using Testcontainers Cloud, we're able to give you better debugging information. We're able to give you each individual session that has run this test containers. What were the dependencies? What did you spend time on? So on and so forth. And what we're shipping shortly is we're shipping the ability to pin a particular session. So when you're doing your CI builds, you're able to say, hey, when you're done, please don't take this container away. I want to be able to SSH into it, and I want to be able to see what's the data inside of that container. And finally, by using Testcontainers Cloud, what we're able to do is we're able to provide things like Turbo Mode. Turbo Mode notifies us that as opposed to giving you a single VM to run your dependencies, we're actually able to break that dependency. We're able to give you multiple VMs to run your tests. And that allows you, for example, in CI to have a much faster execution, right? Because you no longer are dependent on a single machine or a single worker where you're running your tests. A few folks who have used this, Roberto from Netflix, who is running this Testcontainers Cloud, and Nikolai, who's actually based out of here in London, specifically on using Testcontainers Cloud with their test setup. With that, just wanted to provide a few resources. Testcontainers.com is home for all things test containers. Testcontainers Cloud is the service that I just talked to you briefly about, and Slack, which is our Slack instance. We're also downstairs, one of the booths. If you want to come and talk to us in person, we'll be there for the next few days. I have 3 minutes over here, and I'm happy to take any questions. Any thoughts? Oh, there is a question right there.
Slightly confused. Sorry, I'm slightly confused. You said that your code never leaves your machine.
Yes.
How does this work exactly?
So when you run Testcontainers Cloud, your code runs on your machine. Your code, when a test case runs and Testcontainers requires to spin up a dependency, the dependency is spun up on the cloud. Your code never leaves your machine. Your code communicates with that dependency as if though it was local. So it forwards the request. So your code stays local, the dependency stays up in the cloud. When the test is finished, the dependency goes away. Your code never leaves your machine.
Thank you.
No problem. Any other questions? Thoughts? Oh, there is one over there, and then I'll come back to you.
Hello. So sorry, is there today visibility on the logs of the container or not yet?
We are shipping that within the next week or so. Yes, we will give you visibility into the logs of the containers. There is one question over here.
Yeah, kind of a feature request. We're using a temporal.
Mm-hmm.
Are there any plans to create a test container for that?
There are active
is there
discussions.
something I can do to
yes.
get it in?
So the founder of Temporal is a very good friend. And last time we were in London, which was about a month ago, we discussed this. If that is of interest, happy to pick that conversation up.
Okay.
Any other thoughts, questions? All right. Thanks, everyone. Thank you for coming. Thanks.